Friends, welcome back to a new session. So in this video we are discussing about Rolle's theorem. So let's begin the session. So before starting this session, don't forget to subscribe our channel for more informational videos. So let's begin. So let's learn about Rolle's theorem and one question based on it and how to prove this question by simply using the basis of the Rolle's theorem. So by Rolle's theorem, there are three conditions existing. The first one is when we taking a function as f of x or f, then it is continuous on closed interval ab. And the second condition is when we taking a function that f of x which is differentiable or derivable at a open interval a comma b. And the third one is the important one, which is f of a which is equal to f of b. So when by Rolle's theorem the given function is attaining the three conditions, then we can say that by Rolle's theorem there exists at least one value c in open interval a comma b, then it become that is f dash of the point c which is equal to 0. So these are the basic property that is under the Rolle's theorem. So let's solve some question based on these properties. So it helps us to understand more things about Rolle's theorem. So let's begin. So let's do some questions. So here the given question is verify Rolle's theorem for the given function f of x which is equal to sin x divided by e raised to x with the given interval is that 0 comma pi. So let's find the solution for this given function by using the Rolle's theorem. So by the first point of Rolle's theorem, we can understand that f of x is continuous on closed interval ab. So here given that a interval 0 comma pi with a function also. So we can say that the given function with which contain the numerator contain trigonometric and the denominator contain exponential. That is the combination of the trigonometric and exponential function. So it means that the given function f of x which is continuous on the interval is 0 comma pi with closed brackets, that is the closed interval 0 comma pi. So the first property is satisfied. In the second case we want to note that, so in the next step it become, this is the first step, in the next step f of x is differentiable or derivable at the open interval a comma b, which mean that we know the function f of x is given that sin x divided by e raised to x. So when finding the f dash of x here, so here we can use the coefficient rule. So we can find the solution for the sin x divided by e raised to x or its derivative by using coefficient rule. It means that sin x into derivative of e raised to x which is equal to e raised to x minus the function in the denominator is e raised to x into the derivative of sin x d by dx of sin x which is equal to cos x, then whole divided by the term in the denominator which whole square. So we get a term by the coefficient rule also. So it means that by solving these things or taking these e raised to x into the outside of the bracket, then it become e raised to x into sin x minus cos x whole divided by e raised to 2x. So it means that we can cancel these e raised to x and another e raised to x. So we can write this e raised to x in the denominator as e raised to x into e raised to x also. Then we can cancel 2 e raised to x. So it become sin x minus cos x divided by e raised to x. So we get a function like this one. So there is no need to a further simplification here. So it become, we know that we understand that f of x which contain a defined f dash of x which is equal to sin x minus cos x divided by e raised to x here. It means that the function f of x is derivable or differentiable at the given interval, that is open interval 0 comma pi here. So we achieved the second property also. So in the third thing, it is a very important by the Rolle's theorem, that is f of a which is equal to f of b here. So note here that by third rule it say that f of a which is equal to f of b. It means that we know the value for a comma b. It is in the interval. So the given interval is 0 comma pi here. So the value for a which is equal to 0 and the value for b which is equal to pi here. So by substituting these things in the given function, or we want to find that f of a, which means that f of 0 and f of b which is equal to pi, that is f of pi, and we want to show that this f of a which is equal to f of b, that is f of 0 which is equal to f of pi here. So here the given function f of x which is equal to sin x divided by e raised to x. So we want to show that f of 0 which is equal to f of pi. So let's check it out. So when putting these x by replaced by 0 and x replaced by pi, then we get it as in the left hand side, that is LHS and RHS also. So in the case of LHS, it becomes sin of x which is equal to 0 here divided by e raised to 0. Then which is equal to, we want to show that which is equal to RHS. The RHS which is f of pi. F of pi means that sin pi divided by e raised to pi. So here note that the value for sin 0 which is equal to 0 also, and e raised to 0 which is equal to 1, which is equal to sin pi which is also equal to 0. That is the value for sin 0 and sin pi which is equal to 0. And here in the denominator contain e raised to pi. So it is a constant term. So we can also write that thing here. So which is imply that 0 equal to 0. It means that LHS which is equal to RHS, or the third condition is proved from this Rolle's theorem, f of a is equal to f of b here. That is 0 is equal to 0. Then at last we can conclude that there exists at least one value c, that is c is a constant value in the given interval a comma b. So in the question the given interval which is 0 comma pi. So then we can conclude that f dash of c, that is the derivative of the function with the point c which is equal to 0 in nature. So let's check it out and find the value c from that derivative thing. That is, now we can say that f dash of c which is equal to 0 here. So the three properties of the Rolle's theorem is proved now. So we can conclude that f dash of c is equal to 0. So it means that from here we can find the value of c which belongs to the given interval 0 comma pi. That is the given open interval 0 comma pi. So here f dash of c is equal to 0. We now, or we derived that f dash of x which is equal to sin x minus cos x divided by e raised to x, which is proved in the second step. So note here that from here we want to replace x by c here. That is f dash of c which is equal to sin c minus cos c divided by e raised to c, and its value which is equal to 0 also. That is we taken as f dash of c which is equal to 0 in nature. So here we can take this e raised to c in the denominator into the right hand side from the left hand side. So it becomes sin c minus cos c which is equal to 0 also. So it means that we can write it as sin c which is equal to cos c. So note here that the value of c which is contained when the sine function which is equal to cos function also. So by concluding this condition, the value of c is satisfied by this condition is pi by 4 here, which means that the value for sin c, that is sin pi by 4, which is equal to 1 divided by root 2, and cos pi by 4 which is also equal to this 1 by root 2. That is 1 by root 2 which is equal to 1 by root 2. It means that there exists a point c is equal to pi by 4. It means that finally we conclude that from these three properties, first we say that it is continuous, second we say that it is differentiable, then we can conclude that f of a is equal to f of b, then finally we can conclude that at least one point c in the given interval a, then f dash of c which must equal to 0 also. It means that by using the f dash of c which is equal to 0, we can find the value for c by using these equation, that is we done it as from f dash of c, that is sin x minus cos x divided by e raised to x, which is the f dash of x here. When replacing x by c, then after some calculations we can conclude or we can find the value of c, that is a point c which between the given interval, that is finally c is equal to pi by 4, which also belongs to the given interval 0 comma pi. So finally we can say that hence Rolle's theorem is proved for the given function f of x, which is equal to sin x divided by e raised to x in the given interval 0 comma pi. So in this session we learned about Rolle's theorem and its advantages and how to prove this Rolle's theorem or the given question. So let's wind up this session and see you soon with a new video with more and more educational contents. So don't forget to subscribe our channel for more informational videos. Stay tuned with us.